Welcome. In this video we'll discuss the EC2 storage options. We got mainly two major storage options, the elastic block store and the instant store. So like everything else in the cloud, the storage volumes holding your instance OS and data are going to be virtual. In most cases that means the 20 or 30 gigabit drives, or maybe 2 terabytes, right? Holding your application is really just a 20 or 30 gigabyte partition, cleverly disguised to look like a standalone device. In fact, it was actually carved out of a much larger drive, maybe a petabyte even, So what's going on with the rest of the drive space? It's probably being used for instances run by other customers. Some instance types support only volumes from the elastic block store. Others get their storage from instant store volumes, and some can happily handle both. The physical drives where an EBS volume actually exists may live quite a distance from the physical server that's going to use the instance. Or use the drive space. Rather than connecting directly to the motherboard, say via a SATA cable, the way a physical drive plugs into physical computers, EBS volumes speak with your instance over a super low latency network connection spanning the data center. As fast as the EBS EC2 responses are, they're still not quite as good as the experience you'll get from the EC2 Instant Store. So what does EBS offer to compensate? Well, unlike the Instant Store, that's ephemeral, right? The data store on EBS volumes will survive shutdowns and system crashes, where the Instant Store, if you shut the system down or reboot, you'll lose the data. This can be a factor for workloads where data persistency is necessary. EBS volumes can be encrypted, which when you're working with sensitive data can make a huge difference. EBS volumes can be moved around, mounted on other instances, as you have seen, and then also converted into AMIs. Where instance stores are attached directly to the system. Unlike EBS, the instant store volumes can enjoy the benefits of having their data on physical drives attached directly to the physical instance. The downside of instant store is it's ephemeral and it has no encryption and its lack of flexibility. They are offset by the faster data reads and writes, and this can be useful for processing and analyzing fast-moving data streams where the data itself doesn't need to be persistent. So, it's got a good trade-off, right? EBS volumes are permanent. They can be moved around. They survive. Turning the server off. And on. So they're your good standard base drive. Is the EBS volumes. They're what you should put your OS on, etc. Whereas the Instant Store, they're more temporary scratch type drives, but they're physically located on the server, attached to the server. They're faster because they're not having to traverse the network. But if you shut off the system, you'll lose the data. So you need some way of replicating that data or getting the data back, but it is much faster. So there are ways to utilize EBS and Instant Store together, or we'll also talk about much later, EFS and S3 as potential ways of storing the data permanently and then refreshing your Instant Store. So there are ways and solutions to keep the data after a reboot, after a system shutdown. But it's not ideal and perfect if you absolutely need the data to persist. If you need the data to persist, then EBS and EFS are probably options for you, with EBS being a little faster probably than the EFS, but we'll get into that much later. So EC2 pricing models, right? So what will you pay for the EC2 instance depends on the way you consume the service. Here's what you'll learn about consumption about EC2, right? So you have on-demand instances, right? So this is the most expensive pricing tier, and where you pay for every hour the instance is running, regardless of whether you're actually using it. Depending on the instance type you're using and the US and the AWS region that it's running in, you could pay as little as half a cent, an hour, or for a T2 Nano, or as much as 24 or 25 bucks an hour from one of the larger instance types. On-demand is great for workloads that need to run for a limited time without interruption. You could, for instance, schedule an on-demand instance in anticipation of increased requests against your application. Perhaps your e-commerce site is offering a one-day 50% off sale, and so by running an on-demand instance 24/7 for months at a time when you need it only for a couple hours a day, it's going to cost you far more than it's worth. Instead, for your use case, you just consider running it for an hour or two for that one day, on demand, and it's going to be a lot cheaper than paying for it for a full month in some of the other models. All right, and so besides the on-demand, we have the reserve instance, right? So if your application needs to run uninterrupted for more than a month at a time, then you'll usually be better off purchasing a reserve instance. Practically, however, you're unlikely to find an available reservation with a term shorter than 12 months. So 1 and 3 years are always available. As it turns out, when you go shopping for a reservation, you're not actually purchasing an instance of any sort. Instead, you're paying AWS or another AWS customer who are selling their reservations that no longer use it for the right to run an EC2 instance at a specified cost during the reservation term. Once you have your reservation, it will automatically be applied against any instances you launch in the specified AWS region that matches the reservation instance type. So if you purchase a reservation for a T3 micro for 3 years, whenever you run the T3 micro, it goes against that reservation first. But of course, if you ran, say you ran 10 T3 micros, for 5 hours, right? So that would be 50 hours of your reservation time. 10 instances at 5 hours, right? So you can do that as well. There comes a point where a reservation does make sense to go ahead and purchase that and save your money if you need a lot of consistent compute power and certain instance types. But reserve instances are also paid in 3 ways, right? So all up front, partial up front, or no up front. And of course, the more you pay up front, the less it'll cost overall. Now, besides on-demand and reserve instances, there are spot instances. And these are for workloads that don't need to run constantly, and the workloads can survive unexpected shutdowns. Your cheapest option will probably involve requesting instances on the EC2 spot market. AWS makes these unused compute capacity available at steep discounts, sometimes as much as 90% off the on-demand cost. The catch is that the capacity can in any 2 minutes be reclaimed and shut down. So if your bid for the spot instance gets outbid, or the capacity goes away, you can lose the instance on the spot market. So that's why your workloads have to be able to recover from unexpected shutdowns. But if it's something that that's just like processing a queue and doing things, and it can reassume and re-pick up and pull work off the queue when it comes back, and that workload can survive for down periods, where you may be an hour or two or so before you get another instance, or maybe even a day. That's the kind of workloads that spot instances are meant to help provide a solution for, and they're very cheap. And so if you can find a use case that is workable in the spot instance environment, you will definitely save a ton of money running spot instances versus on-demand or reserve instances. But it wouldn't be an option for many of your traditional use cases that require persistence and predictability. For example, you wouldn't run your web servers on your spot instances, but maybe you could run a few additional web servers on a spot instance, as long as you had your dedicated guaranteed amount, and you ran spot instances for additional web servers just for certain points and days where workloads are heavier, that just give it a breather, and so you might run them. It might be okay, depending, as long as there's no state that's being saved by the web servers. If state is handled somewhere like a database or something, you might be able to do that. But typically your web servers wouldn't be a good option for that, because you need some persistence and predictability. But it is perfect for certain classes of containerized big data workloads, or test and development environments. Things of that nature could really benefit from spot instances. Spot deployments can also be automated by defining your capacity and pricing needs as part of a spot fleet. The use of spot instances can, in addition, be incorporated into sophisticated multi-tier operations that are deeply integrated with other automation and deployment orchestration tools. It is a viable solution in a lot of use cases, and it is much cheaper to do spot. But so we have the three pricings: the on-demand, reserve instances, or the spot instances. That is it for this video, and we'll pick up in the next video, and we'll start covering some of the managed services such as Lightsail and Elastic Beanstalk. See you in the next video.